All right, guys, welcome to the last chapter of, of the course, really. We're going to get into something called trigonometry. And I'm sorry, trigonometry is going to be the easiest math subject that you are ever going to really struggle with. And why is because it's very different concept than pretty much anything you've looked at before. And what I've found with most students is that they have a really hard time with it, really hard time with it, really hard time with it. And then one day the clouds part, the light shines on them, and everything makes perfect sense. And they sit there and wonder why they had troubles. Um, Once you get it, you get it. Everything suddenly makes sense. All the pieces fall into place. Whatever other cliche you can think of in this spot. But until you have that moment, you're going to be frustrated. And I would love to say that there is a easy way to learn it. I've just sort of learned over the years that you got to power through it, suck it up, deal with it until illumination comes. All right. So with that in mind, let's start in on some basic definitions. So we already know from our days dealing with Pythagorean theorem that the hypotenuse is the longest side in a triangle. Okay, it's always across from the 90-degree angle. Now, hopefully you know English. The side across from something is opposite. Okay, most people know this word intuitively from the English language and understand it. The one they have troubles with is the word adjacent. And the word adjacent, all it means is beside. So two people sitting beside each other in class, they are adjacent to one another. These are actually the second two are actually everyday words, although we don't use adjacent very often. And the reason I bring that up is that the names of the sides actually change relative to the angle that we're looking at. So here we're looking at this angle down here, which means the side across from it is opposite, and the side that's touching it is adjacent. As always, the side across from the 90 is your hypotenuse. So have a quick look at the second one. If the angle is now up here, that's a 90-degree triangle. Where's your hypotenuse? Where's your opposite side? Where's your adjacent? As always, if you need a little more time, pause it. I'm just going as though you had time to think about it. Videos can be long enough as it is. The side across is opposite, and the side beside it is adjacent. Now, what a lot of people do is what I just did. You guys are all comfortable with the hypotenuse, so that usually is the first one that gets named. By the English language, you usually understand what opposite means, so you're able to name 2 out of the 3 sides. The third side, you might not know what adjacent means. Like I said, it is not a common word in the English language, but if you've named 2 out of 3 sides, the third one must be the adjacent side. So until you get comfortable with naming things on your own, that's a good way of approaching it. Now, I want you to notice that the names of the side change when the angle moves. Okay, so they're actually not the exact same triangle. Well, whatever. When the angle was in the bottom right, it was adjacent hypotenuse. When the angle was in the bottom right, these sides changed. Notice that the longest side is still the hypotenuse, but which side is labeled adjacent depended on where that angle was. Now, the other thing I want you to notice is that we use theta. We still use x. We still use the old way of marking down what sides are, angle A, B, C. But theta gets used a lot to represent angles. You're also going to see alpha and beta. I don't know why Greek letters get used for angles, but they do. You will still see X and Y. So why is trig important? What is the point of us going through all this? Well, it turns out that triangles with proportional sides, proportional lengths, have the same angles. So while that probably means nothing to you, I want you to notice on these two triangles, they have the same angles. So when we find the ratio of the opposite and to the adjacent, we get 5 over 10, which reduces to 1 over 2, or 0.5 if you prefer the decimal place. Well, here we've got the same thing. Opposite, adjacent, well, that's 10 over 20, which reduces to 1 over 2. So our proportions are the same. The ratio of the sides are the same if it's the same angle. And this allows us to do a lot of crazy stuff in math with triangles. It becomes pretty important in physics and other stuff, but well, you'll get into that stuff next year, if you're lucky. So matching side ratios to angles has allowed math people to find unknown lengths and angles, which is what we're going to focus on. And there are 3 separate relationships that we use that we call the 3 primary trigonometric relations. Usually we just call them the 3 trig ratios. However, they are sine A, which is defined as opposite over hypotenuse, or op over HYP. Now you can use O. I don't like it though, and the reason why is it's far too easy to confuse an O with a 0. Cos A is defined as being the adjacent. I can spell adjacent, but I'm not going to. Oh, I did spell adjacent. That wasn't so bad. Over the hypotenuse. As always, I will come along afterwards and fix this up so that the PDF has better handwriting. And tangent is opposite over adjacent. Math people are big on toa, which is a short way of remembering the names. So notice sine theta equals op over hype. So it actually gives you the formula. Sine, opposite divided by hypotenuse. Cos, adjacent divided by hypotenuse. Toa, opposite divided by adjacent. So it gives you the formula and a quick way to remember it. Now, one thing we got to get into before we do anything else is that everything we are going to do is going to be in the degree mode. I wish I was there to help you because I could, show you on your calculator how to figure out whether you're in the small d or DEG mode, and then I could help you adjust your calculator so that it's in the right mode. You will get the wrong answers even if you're doing it correctly if your calculator is in the wrong mode. So part of what we're going to do right now is we're going to look at how to use your calculator and make sure it's in the right mode. And again, I wish I was there to help you out, but every calculator is different. Some calculators are going to expect you to put in 82 sine, and some calculators are going to expect you to put sine 82. You need to know your calculator and you need to know how it works. So this is a test of, this is you learning how to use your calculator and making sure that you're in the right mode. So when you put this into your calculator, you should get these values. Okay. Now, kind of a segue, one of the common questions I get is what does sine mean? What does cos mean? What does tangent mean? And their names, okay? They really, what does, I don't know, Smurfette mean? And there is no meaning to the word Smurfette. It is the title given to that person, or Smurf, to identify that Smurf. And that's exactly what it is here. So sine is just the name given to opposite divided by hypotenuse. There is no special meaning. That's it. Why is it sine? I don't know. It was made up by some Greek guy like 2,000 years ago, 3,000 years ago. So I'm assuming that there is some Greek meaning to it somewhere, but nothing that really matters to us. All we need to know is that cosine means the adjacent divided by hypotenuse. Hopefully that helps the clouds part a little bit sooner. A lot of kids get bogged down in that detail, and it's not an important detail. Now, hopefully your algebra is strong enough that you can do this on your own, but we're going to do a quick little run through. So if you put in your calculator sine 23, in order to solve for x, we have x divided by 5, so it means we're going to multiply both sides by 5. Now, I don't expect you to write this out, this step anyways, but for me teaching you, I'm going to put it in. Now, notice I'm working to 4 decimal places. And the reason why is it's accurate. If you want to play, you're going to find that there is a difference between, you know what, we'll get to that tomorrow. We'll get to that tomorrow. Just get in the habit of working with 4 decimal places. Now, the one that's going to mess a lot of people up is this one, because a lot of people forget that for division, order matters. All right. Last little bit that we're going to look at, just simply identifying. So if we have 7.3 over 8.5, and we're using angle G, so 7.3, 8.5, it means we have the adjacent and hypotenuse. Well, if we go back up to our formulas at the top of the screen, where'd we go? Adjacent and hypotenuse is cos. So we're finding cos G. In this case, we're being given tan of G. Well, that's opposite over adjacent. Go ahead, look it up. Which means 4.4, right? Because that's opposite. And we've already said 7.3 is our adjacent. I'm not asking you to solve. I just want you to show me what is the ratio. The whole point of today's lesson is to get used to the concept that there are these 3 trig ratios that I've never seen before, and that naming the sides of a triangle changes depending on where that angle is. You get that sorted out today, and life will be considerably easier. Because honestly, the hardest part that people have with trig isn't remembering the trig formulas. That actually comes pretty easy with SOHCAHTOA. It's remembering what side is what and that it moves. All right, guys, that's it for today. You can see your homework assignment down here. As always, if you have a question or concern, shoot me an email, shoot me a text. Life is good.